Now let me dive into the demo. So as I said, there are multiple options. I can always start a new analysis and upload PCAPs manually through the UI. But of course, as I said, the end-to-end automated process, hands-off, headless persona is also available, which can be integrated using APIs. Now, I already have some files that are uploaded here, and today, for the purpose of this demo, I'm going to be taking some examples of EPS Fallback, essentially because it's a hairy call flow. It involves both domains, and it is a classic use case for troubleshooting purposes in the journey of evolving from 4G to 5G, right? And Agility can also accept zip files, which means I could have hundreds and thousands of PCAPs bundled into one zip file, and I can feed that to Agility, where I can have the complete analysis available for all of those PCAPs, right? Now, what happens once I upload those different files, right? The first view that I mentioned is the high-level summary view that Agility provides. So as and when data keeps coming in real time, the analysis is also available in real time as seen here, right? So that essentially covers the quality and the performance part of it. As I was mentioning, it is more of a proactive approach than a reactive approach. And then one can dive into the different aspects of troubleshooting from here, right? So I, of course, have the EPS fallback flows already executed here. And for the purpose of the demo, I'll actually dive and focus into how Agility breaks down the PCAPs and the different kinds of insights that it provides. The first one, as I was mentioning, is the high-level summary. So it looks at, services that are detected, which means while I'm processing those PCAPs, I can actually apply a service model against that PCAP, which means for all EPS fallback PCAPs, I can apply a model that looks and evaluates all the end-to-end EPS fallback messages, right? And that's what it's telling me. It's telling me that there was one service related to 5GSA mobility or EPS fallback detected. It also detected about 28 network functions. Now, this is where I will stress on the fact that dynamic topology mapping is absolutely crucial in order to swiftly identify which network function is causing the failure instead of having to rely on host IP mapping files. So that's where Agility is providing information on the unique types of network functions that it detected. It is also looking at the various subscribers, and right, because ideally, as I said, a PCAP can be a black box. There could be multiple subscribers for various activities, and it is important to correlate each one of those subscribers for their call flows. And ideally, this is a very time-consuming process, right? Along with that, Agility also provides the total number of call flows detected. A call flow is actually a unique attempt for an EPS fallback. In this case, it can be applicable to Warner, connectivity, data, and many other services, right? Along with that, Agility also provides the pass-fail distribution. So of course, the top level is sort of the more high-level picture, but out of that, it's also providing the health of each of these KPIs, which means how many network functions were impacted with failures, how many subscribers were really impacted with catastrophic failures, and how many of those call flows were impacted as well, right? Now, from here, I can actually dive individually into the way I prefer to look at these KPIs. If I'm interested in subscriber level information, I can always dive into the subscriber level information here, right? But if I'm interested in, let's say, if I go back to that same analysis that I have here, if I'm interested in the call flow level details, I can always focus on every call flow that was dissected in the PCAP by Agility, right? And this is where, as I mentioned, the machine learning model provides classifications. The first one is either could be a success or a failure, or a success with warning as well. Now, what's a success with warning? It is essentially patterns where there are intermittent failures. These are not catastrophic failures. These are more failures which are not causing essentially a call flow to break down per se, right? From a functional standpoint, an end-to-end call looks successful, but maybe there are excessive amount of delays, there are excessive retransmissions, retries, and these kinds of things, right? So that's where the model can also classify them as success with warnings. Now, that's the first level of classification that agility provides. The second level of classification is the root cause itself. In cases of success, of course, you will see a successful classification, but in cases of failure, you will see an actual root cause that is associated with it, right? In this case, it's the model is telling me that the classification is an EPS fallback handover failure at the GTPv2 layer because of the cause 81 relocation failure between the MME and the AMF, right? So it's really telling me which service, what's the procedure that failed, the protocol that failed, or where the failure is, the cause, and the interface as well. Now, the failures can actually be spread across multiple layers. And what do I mean by that? As in, some of them could be as simple as there was no packets of interest discovered in the call flow, right? So it's essentially eliminating time to try to skim through packets and see if there is anything of interest present there. It could be as simple as an explicit failure, as I mentioned, or it could be missing requests and responses also, right? In this case, the bottom one below that I'm highlighting here, it is in fact quite a lengthy explanation that it's telling me it's a tracking area update failure on the GTPv2 protocol for the IMS APN where create session request is not being answered. And it's also telling me why it's not being answered is because the preceding step is responding in a 100 remote peer not responding failure between the S gateway and the MME. So in this case, I really know that the problem lies at the S gateway level, and I need to go back and check why S gateway is not accepting the create session request for the IMS APN, right? So that's the first level of classification that agility is providing. For failures, it provides insights into where the call flow is failing and why is it failing, right? And alongside that, as I mentioned, agility provides various triaging aids to be able to troubleshoot that. If I were to go back at one of the failures that we were looking at earlier, I know what the machine learning model is classifying in this case. But if I want to be able to support that triage process and expedite it, agility provides these 5 different triage validation functions. The first one, as I was mentioning, is a sequence diagram, right? Now, this sequence diagram is an interactive sequence diagram. The first thing is it automatically builds the topology by mapping the IPs, which means as you see, each map IP has been mapped to a network function across the 5G domain and across the 4G domain as well. So in this case, I really don't have to rely on a host IP mapping file in order to look at which network function this belongs to, right? And that really eliminates the problem of network functions being virtualized today and IPs being dynamic. In fact, we have seen cases where the same IP can be assigned across originating and terminating nodes. So ideally, I would have to flatten out that topology in order to look at the message exchanges between both domains, right? So that's the sequence diagram that agility provides. And this is a multi-layered sequence diagram, which means the different protocol interactions for EPS fallback have all been plotted here in a time sequential manner, along with attributes that are exposed in the sequence diagram. So I can always click on the I information and I can look at further detailed message attributes from there, along with frame numbers and timestamps that this packet belongs to. Right? Now, it is also interactive in the sense that I can apply filters. Right? If I look to troubleshoot these call flows in a much quicker way, I can actually hone into protocols itself, right? So if I'm troubleshooting, let's say at the IMS layer, and if SIP is having a lot of issues, I can apply a filter for SIP and troubleshoot the call flow much more quickly. Or if I'm interested in looking at the SBI-based exchanges on 5G core, I can filter the call flow for HTTP2 only, and I can look at the different network functions that were invoked. So it is interactive in that sense. The second filter I can apply is by either a request or a response. Now, this typically helps me look at missing requests or response type issues where I can look at a message that made it to a node, but maybe was not propagated from there or not get a response back. So that can become my point of investigation. And then also agility allows to filter by the message type itself. And then also you can filter the sequence diagram quickly just to show explicit errors in the call flow, right? As I mentioned, the final classification for provided by the model was a handover failure, GTPv2 81 relocation failure at the MME, right? But once I look at the errors in the call flow, there seem to be a lot of intermittent errors as well, right? I see certain 404 not found for get procedures from the UDR. There's also 404 not found from the PCF. And then, of course, I see something on the N2 side as well. I look at handover failure in handover preparation. So there are a lot of failures that are happening, which are cascaded to the radio interface. But really, one of them is the true root cause of the failures here, which is the one that the machine learning model classification provides, which is this one, right? And the node that causes the problem is also highlighted in red in order to be able to expedite the troubleshooting process, right? So that's one of the triaging aids. The next one is, if I flip over, I can actually quickly look at a topology diagram that Agility builds as well. This is dynamically constructed from the PCAP based on the network functions that were detected across various domains. So if I'm looking at, let's say, just a 5G connectivity call flow, I will only have RAN and 5G domains. I will not have any EPC involvement. But since this is EPS fallback, it involves your network functions from both domains. So that's really the sequence diagram that dynamically builds the topology and expedites the troubleshooting process by plotting all the different messages across the call flow. The next tab is the level analysis. Let me just collapse this. The next tab is the protocol level analysis. As I was mentioning, in order to be able to troubleshoot packet captures and a call flow, there are multiple protocols that are intertwined, right? In EPS fallback case, there is NGAP, HTTP2, PFCP, GTPv2, diameter, S1AP. There is SIP as well for, of course, your IMS handshakes. There could be multiple other protocols as well, right? Depending on which layer you're troubleshooting at. So that's where Agility actually automatically breaks down the analysis per protocol, which means actually even before that, the first thing that Agility provides is whether this protocol was indeed available in the PCAP or not, right? So for the ones that are not discovered, it could be that the protocol was not captured, or probably the call flow truncated before that protocol could be invoked. Now, for protocols that are indeed invoked in the PCAP, Agility evaluates each one of the sub-procedures for that protocol, right? As I said, EPS fallback will have your 5G connectivity. It will have some mobility management procedures, session management for data, of course, branching out to your internet network. You'll have your IMS specifically for voice. You'll have all your 5G HTTP2 SBI exchanges. And then, of course, you will have your PFCP for packet forwarding, N4 setup, and then you will have GTPv2 for your N26 handover towards LTE, right? So a lot of correlation has to be performed within each protocol and also across multiple protocols to isolate root causes. So that's where Agility is automating that core task of bundling these protocols together, right? And it also provides a failure indication where essentially there are intermittent errors or catastrophic failures. For example, in the UDR query for SMF, looks like there was a 404 not found, and it provides really the point of failure or the cause of failure for it as well, right? In the detail description, like in this case, the query for SMF registrations call to UDR failed, and that was the received status for it, right? So that's where I can really hone into and troubleshoot. Along with that, I see that, this is really where the core of the problem was for this call flow. The forward relocation request responded back with the 81 relocation failure, and that's where the N26 handover is failing. So I need to go back and reflect on why the MME is not troubleshooting from here. But this is one example. Now, if I were to ingest hundreds or let's say thousands of PCAPs together, that's where the potential of applied AI can be harnessed to provide different kinds of signatures that are coming out of these PCAPs for every subscriber. Now let's look at a little, maybe one more call flow. In fact, the last one, right? And I'll talk about the remaining triaging aids with those. Now, this one was really a signature where there was no response for the create session request, right? We did see that tackled here. And if I were to filter this call flow to show errors, again, I see a lot of failures, cascading failures across multiple network functions. Some of them are in the IMS layer with SIP failures. Some of them are S1AP based. I see a tracking area update reject. And then, of course, I see GTPv2 based failures as well, right? So this is where it becomes critical to identify that single point of failure where the root causes are occurring, right? So that's where the model is essentially honing in to this one single message. There was no response received for this, right? As you can see, the message cause is also detailed along with remote peer not responding, right? So that's how it is able to accelerate the troubleshooting journey. The third tab is your flow extractions tab, which is similar to what you would see in packet analyzer tools, but this is cutting out all the background noise, not contributing to an EPS fallback call flow, right? There could be a lot of TCP packets, may not be of interest. There could be some UDP packets that may not be of interest. So that's where agility is only filtering those packets of interest that contribute to an EPS fallback call flow, along with expose different kinds of attributes, right? So if I'm looking at the SIP layer of the call flow, I would need to look at the URI, the to from addresses, some of the maybe the STP attributes, and all of those are exposed in the dropdown here, right? It'll also tell me which access network information it belongs on, so I can confirm the validity of this call flow. So that's one of the triaging aids. The next one is called the diagnostics, right? Now, this is where I was talking about large language, applying the potential of large language model on knowledge-based integrations for potentially any knowledge base, right? Such as reference standards or vendor documentations, historical tickets, and other data sources, right? So this is where, for this root cause, agility is looking up the 3GPP standard and providing an explanation of what a remote peer not responding means, right? In this case, it gives a full detailed explanation of why this kind of failure can typically happen. I have some more examples to showcase the potential of diagnostics and essentially looking at more data sources. I have a few more files that I'd executed here. There was a very specific signature coming from 503 service unavailable. That's a very typical failure to see for voice-based services. And in this case, it is an example of a call flow from VoLTE map breaking out to PSTN networks, right? So that's where it's very important to see cross-domain functionality as well, and agility can evaluate these kinds of call flows. So in this case, it's failing. It says it's a 503 service unavailable, but if I go to the diagnostics, this is where there's quite a detailed explanation of why this 503 service unavailable is happening, especially because it's connecting to an ISDN network. There is a cause associated in the SIP sublabel, that's had to look it up. There you go. It says a Q850 cos 41, which is thrown by the ISDN terminal. And that's the diagnostic explanation for that, saying cos 41 temporary failure indicates that the network is not functioning correctly and the condition is not likely to last for a long period of time. So, and it references multiple other documentations to provide detailed explanations of what this root cause possibly means, right? So that really expedites the entire troubleshooting process in order to be able to isolate root cause issues much faster. Also looking at specifically which domain it occurs in, right? Oftentimes it's a lot of finger pointing between, is it really a device issue? Is it a RAN issue? Is it a core issue? Where should I really start, right? So that's where agility is actually helping point the node at which the failure occurs and the cause associated with that. So I can start my troubleshooting from there and extend into other external data sets or integrate with many other data sets like function logs or Jaeger traces or transport layer traces and things like that. The other thing, the tab is the KPI analysis tab, right? Okay, so this is an EPS fallback call flow. Maybe I won't have an example of KPI there, but I can look at a VoLTE example, for example, right? So this is where agility can compute a lot of KPIs from PCAPs. And this is completely customizable. We know that packet captures can provide a lot of information in terms of the times, the time that it is taking for call flows to set up, or look at who's the most talker, who's the most listener, how many retransmissions are happening. All those statistics can be derived, and that's what agility provides. But this is completely customizable depending on the service, right? So for voice, I can look at call setup times and latency, but for data services, maybe latency is more applicable, retransmissions or corruption rates, and these kinds of KPIs are very valuable there, right? So that was essentially, just a quick demo of agility and applying AI and machine learning to network troubleshooting, specifically on packet captures, to of course guarantee the quality and the performance, because we're really talking about applying packet analysis at scale, right? Thousands of issues, identifying root causes in more real time than a reactive approach.